talk to you about relationships between tables. And this is the second of two videos for week 3 of our database management course. And I think this is one of the two most important topics in the course, the other one being normalization. So how are tables related? Well, we use this venerable method called entity relationship modeling to describe the relationships between tables. So this is the oldest and by far the most common way for humans to understand a database, constructing an entity relationship model. And it guides us in creating a database. And the model usually comes first, but then gets revised as the database grows and matures. So a database may start out as a few simple tables and end up as hundreds of very specialized tables. And you've already seen an admittedly eccentric example of an entity relationship model, the flights model, in the video called 02A terms. There are two main ways that people usually draw entity relationship models, and that wasn't one of them. The two are Peter Chen's notation, which is usually used in school. I'll show you one example of that. And the other way, crow's foot notation, which is mostly used in industry. And I'll show you several examples of that. That's the notation that I'd like you to use. So there's Chen notation for an entity relationship diagram, and it contains two entities, a person and a tool, and a relationship between them, which is that the person uses the tool. And you notice that the line, see, this could be, this relationship could come out this side or this side or here. So you need a way to know which is the user and which is the usee. And the double line on the one side and the single line on the other side are the way to do that. We need to know what the primary key is, and the underscore under the words ID do that for us. So these are all the purple things are attributes. And there are different kinds of attributes. So this is just an attribute. This is a multi-valued attribute. So the person may have multiple phone numbers. This is a calculated attribute. Um, there's another name for it, which I'm blanking on right now. But anyway, we don't actually store the age. We calculate it from the birth date and the system date. And here is a hierarchical attribute that contains two components. The crow's foot notation is a little bit different. So the crow's foot notation shows here 5 cardinalities from left to right, 0 or 1. So this on this side, it isn't specified on this side, it's 0 or 1. On this side, it isn't specified on this side, it's exactly 1. On this side, it's not specified, and on this side, it's many. And I don't want you to use this one. So this is one that you'll see, but you can always substitute either of these for it. So this is 0 or many, and this is 1 or many. And you should always use the most restrictive applicable notation. So it is the case that this notation is true for this situation, but we want to use the most restrictive applicable notation. We want to be specific about cardinality, how many of one entity relates to how many of another entity. So here's an example of an entity relationship diagram using crow's foot notation. So there are many suppliers, one or many suppliers, and one or many parts. Okay, this is a many-to-many relationship. A supplier may supply many parts, and more than one supplier may supply the same part. And every supplier in our database supplies at least one part, and every part is supplied by at least one supplier. This is a problematic relationship for several reasons. I won't go into all the, you might be able to guess the reasons that it's a problem, but I'm going to go into one specific remedy for this problem in a minute. Here's a different entity relationship. This is the ORCA example. So we have 0 or more orcas in any given pool, um, and and a particular orca inhabits exactly one pool. So orcas inhabit a pool contains orcas. So the thing above the line is read left to right, and the thing below the line is read right to left. And according to this, a pool could be empty. We can have 0 or more orcas in a pool. Okay, here's another one. So suppose we have the supplier and the part, and we have the name of the entity here, but we also have the name of the attributes of the entity here. So a supplier supplies a part, and a part is supplied by a supplier. I guess parts are supplied by a supplier. And again, we see a many-to-many relationship, and now we also are seeing the attributes of each entity. Now I've created an associative entity that lets us overcome the many-to-many relationship. So instead of having this relationship, we can have a zero or many relationship with quantity and a zero or many relationship with quantity on the part side. So suppose that we have a supplier who hasn't supplied any parts yet. We can still have them in the database according to this relationship here, but we couldn't according to this relationship. So I'm going to remove, and I'm sorry, I've added primary keys. So this is one way of showing primary keys in crow's foot notation. And then I'm going to delete the many-to-many relationship and say the supplier supplies a quantity, and a quantity consists of parts. So we have these three um, primary keys, and notice that we have these two foreign keys here that are shown in an oblique font. By the way, this isn't exactly an italic font, it's an oblique font. It's a technical distinction. Okay, so the preceding problem is that many-to-many relationships lead to anomalies in insertion, deletion, and updating of databases. So we look for them. We look for many-to-many relationships in the entity relationship diagrams we draw. We try to remove them by adding associative entities, in this case, an event or a shipment of a quantity of parts. And associative entities are often also called intersection entities, and they're also called junction entities. And the city in the supplier entity may differ from the city in the quantity entity. So the latter is the location where we received the shipment. This is, by the way, from a well-known database that's used in a lot of textbooks and classes, the supplier part database, or the part database, I guess it's called. On the other hand, PID and SID in the quantity entity are foreign keys shown in an oblique font, uniquely describing one instance in each of the other entities. And I've added names to the relationships, since they're above the line, they're read from left to right. Okay, so that's all I need to say about entity relationship diagrams, except there's a lot to do about them. So making an entity relationship diagram, and it can be a challenging exercise. I've shown you the main problem that you'll encounter and a solution, but in the simplest of terms, yours can be much more complicated than that. So go after it. And I thank you for watching and hope to see you next week.